In this video, we will discuss the problem search in a sorted matrix. Problem says that we'll be given a strictly sorted 2D matrix of n cross m size, and we have been given a number x. We have to find whether the number x is present in the matrix or not. Now, what do we mean by the strictly sorted matrix here? So basically, as you keep on moving on in this matrix, the element keep on increasing. Firstly, the element is 1, next element is 5, next you have 9, then after that you have 14, then you have 20, then you have 21, 30, 34, and 43. So as you keep on moving one by one throughout the matrix here, you can see that the elements keep on increasing, and the zeroth element of the next row is greater than the last element of the previous row. So as you keep on moving, the elements keep on increasing here. Now, what is the brute force way of finding the element x? Now, the brute force way is that we can iterate throughout the matrix in the worst case and try to identify whether the element x exists or not. If it exists, we can return true, otherwise we can return false. Now the time complexity for this particular approach will be what? In the worst case, since we'll be iterating throughout all the elements, so the time complexity will be n cross m here, and the space complexity will be what? It will be order of 1 here. Fine. But can we do it more optimally? Yes, we can use the fact that the given matrix is sorted, so we can try to apply Bayes search here. Now there are two approaches of applying Bayes search. Let's discuss the first one. So the first approach of applying Bayes search, that is a better approach, is locate, like using the Bayes search. What we can do is, first of all, we can try to identify the row where the x element might be lying. So we can identify the row where the x element lies using the Bayes search here. Now once we have applied Bayes search for the first time and found out that in which row the element x might be lying, then after this what we will do is, we will after this we will do we, what after this what after this what we will do is, then we'll apply Bayes search within that row. So the first step is to apply Bayes search to identify that which row consists of the element x, and then once you know that row, then apply Bayes search in that particular row itself. Okay, now what will be the approach here? See, initially the low will be updated to 0 because you want to apply Bayes search to find the row which can consist the element x. So initially the low will be 0, high will be equal to n minus 1. Okay, because initially the lowest row in which you can find the element is 0, and the highest row in which you can find the element is the last row. After that, let's say you are at a particular mid row. So suppose that there were certain elements that you already had. Let's say these were the elements that these were the rows that were already filled, and then you are at this mid row, and let's say the elements are 30, 31, 32, 33, and 34, 35, like this, so on and so forth. And let's say this is my mid row as of now. Okay, and there are several elements below this as well, and this is my mid row as of now. Now suppose that my x element that I'm looking for is 35. Now see, if I'm at this mid row, I'll check the 0th element of this mid row. So the 0th element of this particular row is lesser than the element x. So if 30 is less than 35, the expected element was 35 and 30 is less than 35, so the element at the 0th index of the mid row, it is lesser than the element x. In such a case, I can say that my target element x will lie either on this particular row, mid row, or beyond this. So what I will do is, as of now in my row, I'll store this particular mid row, that this mid row might consist of the element x, and after that I'll say that I'll try to search on the right side. So I'll update my low as mid plus 1 here. Okay, this is what I'll do because we need to search downwards here. Otherwise, in some of the circumstances, like you can see that in this case, when the Bayes search will be applied later on, then the actual row that is storing the element 35 will be this row, so it will get updated accordingly. But sometimes what can happen is, let's say the element 35 is there, so it can exist in this particular row as well. Let's say if the output was like this, if the input was like this, 34, 35, 36, and then you had 37 and 40 and 45, like this. So in this row also you can have the element. So in this case, you can see that the element at the 0th index in the mid row, it is lesser than the element x here. So 34 is less than x. In this case, you will say that you will store this particular mid as the mid row as the answer, as the row that you want, and then you will search downwards. Okay, so that is why we are updating the row is equal to mid in this particular case. Now in the else case, if the element in the mid row, if it is greater than x, what does that mean? So let's identify that. Suppose that we are at a particular mid row, and the element here are starting from 40, 45, 70, like this, and several other elements are there. Now if the element of the mid row, if it is greater than your x, if it is greater than x, So 40 is greater than x. If the element in the mid row, if the zeroth element of the mid row, if it is greater than the target element, this means that the target element will not lie in this mid row, and it will not lie in the below. It will not lie in the below rows as well. You need to search upwards. You need to search upwards. So that is why you'll update your high as what, mid minus one, because if the zeroth element of the mid row, if it is greater than my x, then the target element will lie in the above rows. So I need to update my high as mid minus 1 here. This is what I have done. I hope you have understood the logic for finding the row in which my element x might lie here. Now once this is done, so then you can do what, you can check that if you found out a row, because initially you'll keep the row as minus 1, and if the row is not minus 1, if you have a particular row in which you can try to search, you will try to search in that row. Now let's see this particular example here. And once you have that row, then you have to just apply the bind search logic in the row. Now you can see here, let's say the x value here is what? Assume that my x value is equal to, let's say something like 34 here. Okay, now what will happen here? Initially, we will apply the first bind search for finding out the row in which my element will lie. So initially the row will be equal to minus 1. Okay, my low will be equal to 0, and the highest row will be equal to indexing 2 here. Now what will happen here? My mid. So my mid is going to be initially 1. So we will be at this particular row. Initially, we'll check with the zeroth element of this particular row. So we are at 14. Now 14 is lesser than 34. So as of now in my row, what I'll do is I'll update the row value as 1, that maybe in my row 1 the element might lie, but I'll try to search downwards. So I'll update my I'll update my low as mid plus 1. So now what will happen? My low will be equal to 2. Now when I calculate the midpoint, what do I get? I'll get the value that is 2 here. Now we will check, is the zeroth element of the mid row, that is this element 30 of this mid row 2, is it lesser than the element 34, the element x? Yes. So in that case, I'll update the row value to what? To this particular mid, that is 2. Okay. And then we'll try to search in the downward direction. We'll try to search below this row. So what will happen here? The row will get updated. The low will get updated to mid plus 1. So the low now will be equal to 3, and the low and high cross. So then I need to stop, and my row value is what? My row is 2. So chances are that in the second row, my element might occur. In the second row, my target element might occur. So in this case, what will happen is in this second row, we'll apply bind search. And when you'll apply bind search in the second row, you'll be able to find the element 34. Sometimes it might not be present as well. Suppose that the x value was 36, then we would have searched in this row, but the element was not present. So we would have returned false because the element was not present. Okay, instead of x being 34, if it was 36, then the answer would have been false here, because in this last row 2, we expected that the element 36 would have been present, but it was not present if we would have searched it. So what is the time complexity here? If you see, firstly we are applying a bind search on the rows to find out the row which is going to consist of the element x here. So that will take log n time to identify the row. And then once we identify the row, we are doing bind search in the row. Now, how many elements are there in a particular row? M elements are there. So that is why when we are applying bind search in the row which is of m size, which is consisting of m elements, so the time complexity taken for that will be log of m here. So the overall complexity will be order of log n plus order of log m here. I hope that you have understood this clearly. The space complexity will be how much? The space complexity will be constant here, because we are not going to take any extra space here, but the time complexity will be log n plus log m here. Now let us have a look at the code of this particular implementation here, where we are using two bind searches. So you can see here, initially my n value will be equal to what? Initially it will be equal to the length of the matrix. M value will be equal to the column here. Then after that, low, initially we are going to apply bind search in order to find the row where my element might lie. So low is 0, high is at the last row. Initially the row value is updated to -1. Then we try to find the mid, and then if the suppose that the zeroth element of the mid row, if it is equal to x itself, then we have found out the element, then we can directly return true. Otherwise, if the element in the mid row, if the zeroth element of the mid row, if it is lesser compared to this element x here, then we'll update the row to this mid, and then we'll try to search downwards, because like we'll say that as of now we are assuming that the element might occur in this mid row, but let's look downwards, because since the element at this mid index, since the element at this mid row, zeroth element of this mid row, it is lesser than x. So let's update the row as mid, and let's try and search downwards, because the element might lie downwards as well. So we'll update the low as mid plus 1. Otherwise we'll update the high as mid minus 1, because if the zeroth element of the mid row is greater than x, then the element will lie upwards. The element will lie in the upper row, so update the high as mid minus 1. Now if after searching, if the row is -1, so this means that there is no row which can consist of the element x, then return false directly. Otherwise, if you get a particular row, then apply bind search in that row and try to search for the element. So we'll try to do what? We'll try to apply bind search, and we will search the element x in that particular row here. So the bind search logic will be very basic here. So that is why the time complexity for this implementation will be what? It will be order of log of n first of all, because we'll be finding out that row which can consist of the element x, and then we'll apply a bind search in that particular row. So it will take order of log m time as well. So the overall complexity will be order of log n plus order of log m here. Now, can we do it more optimally using one bind search? Yes, we can. So let's see how. So basically, in order to optimize this and solve this problem using one bind search, what we can do is we can try to consider, hypothetically, we can try to consider that all the elements will lie in a single 1D array. Suppose that all the elements are there in a single 1D array. Now, what will happen in that case? If you see, suppose that we have n value as 5 here. If my n value is 5 here, and suppose my m value is also 5, so number of rows and columns are 5. How many elements are there? 25 elements are there. So assume that 25 elements are there. So what will be the starting index? If I'm assuming a 1D array, so the starting index will be 0 and the last index of the element will be 24. That is n into m minus 1. So we'll try to apply a bind search in that range. Now, how will that help us? Like, how will I get the mid and how is that going to help me? So assume for a second, guys, let's say if you see here, so if I'm assuming a 1D array here, so my very first element will be at the 0th index, and the last element, that is this particular element of the matrix, it will be at the n into m minus 1 index. Correct. Now, once I know this, so for this particular test case, what will happen is my low will be equal to 0 here, and my high will be equal to what? My high will be equal to 24 here. Now, if I calculate the midpoint, the mid comes out as 12. Now, when the mid comes out as 12, does there actually exist an index 12 in this 2D matrix? No, there does not exist any index in this 2D matrix which is 12 here, because like having mid 12 does not help me to identify that I am at which particular row and column. So using this mid, I have to identify that I am at which particular row and column here. So you can understand one thing, that this is basically the 0th row. Okay, then this is the index 1 row, index 2 row, index 3 row, index 4 row. Notice one thing, how can I find the row using the mid? So when you will do mid by what? M. Because like when you will do mid by M, you will be able to identify that how many, like you are at which particular row here. So if you will see here, what will happen is my mid is 12. So if I'll do 12 by what? If I'll do 12 by 5, what am I going to get here? If I'll do 12 by 5, I'm basically going to get nothing but the value that I'm going to get here is basically 2 here. So this means that my 12th index element will lie in the index 2 row. So if you see here, let's say 0 was there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see that actually the 12th, if the mid is 12, so this is the element that we are referring to. And it is lying where? It is lying in the second index row. Correct. So how did I find it? By using mid by 2, I was able to find this particular element here. Okay, so I was able to find the row here. Basically, this is the row that I have found out. Now, in this case, the column will be what? The column will be basically mid modulo n. Why it will be mid modulo n here? Mid modulo m here. So when you will see mid modulo m, so 12 modulo 5. What is the remainder when you divide 12 by 5? You will get 2 as well. So accidentally my mid was 12. So the row and the column both are 2, 2, both are 2 and 2. So that is why you can see that the column here is 2 as well. Okay, so this is the element that we are referring to here. Now let's see for some other mid also what will happen in terms of row and column. So let's say if my mid value was what? Assume that my mid value was 24 here. Now what will happen if the mid value was 24? How will the calculations be done? So if the mid value was 24, when you will do 24 by 5, what will you get here? When you will do 24 by 5, you are going to get nothing but what? 4. So when you get 4, so this means that the index 24 element actually lies in the 4th row. So it is going to lie here. I hope you understand this. Now when you will take the mod with 5 as well to identify the column. So for the column, you're going to do mid modulo m here. What will happen here? You will have 24 modulo with 5. You're going to get 4 here. So basically this element, this index is 4, 4. So this is the element that we were talking about. That is the last element. Now let's identify for the mid as at some other place. So let's say if my mid value was what? Let's say if my mid value was equal to, assume it was 5 here. Now what will happen if the mid value was 5? If the mid value was 5, then we are referring to which element? We are referring to this particular element that I've highlighted with the cross here. Now how to find this element? If you do mid by m here, what will you get? 5 by 5, that will give me nothing but 1 here. So index 1 is what I have found out in terms of row. Now what is the column here? So when you will do 5 modulo 5, mid modulo mid modulo m, what are you going to get? You're going to get 5 modulo 5, that will give me 0. So it tells us about the column here. Because the thing is that in order to find the column, I should do mid modulo m, because that will tell me that what is the remainder, and it will indirectly indicate the column number here. So using this formula, using this approach, I can identify that for a given mid, what is my actual row and the index in the given matrix here. Now, once I am at a particular mid, how can I do by search? So if I'm at a particular mid element here that I'm assuming, so I am able to identify its row and the column. Now what will happen here? If you see, if I'm at a particular row and column, so let us say that if for a particular mid, I was able to calculate the row number and the column number, and I'm at a particular row and I'm at a particular column here. Now suppose that this particular element is lesser than x, then what does that mean? If I was assuming that I'm at this particular mid element here in terms of a single D array, and the row and the column are this, and the element here, exactly the element that is there, it is lesser than x. So I need to search where? I need to search on the right side. So I'll update my low as what? I need to search on the right side of mid. So I'll update the low as mid plus 1 here. Okay. Otherwise, what happens is, if the element at this particular row column, suppose it was greater than x. Okay. So if the element that I'm assuming in the 1D array that is at mid, it will be at row column. Now, if it is greater than x, then I need to search on the left side of this mid. Okay. So I'll update the high as what? Mid minus 1. So this is how my by search approach or the logic is going to help me here. Okay. Because using the mid, I'll be able to identify the row and the column. Now once I have identified the row and the column, I'll be able to access that element. And while I'm accessing that element, if that element is lesser than x, then we need to search on the right side. So update the low as mid plus 1, because you want to search on the right side of this mid. Because the element at this mid place, it is not equal to x, it is less than x. So search on the right side, increase. Otherwise, if the element at this mid index is greater, so element at ARR row column, if it is greater than x, you need to search on the left side. So update the highest mid minus 1 here. Okay. So let us do the dry run on this particular test case. If you will see here, we have been given a matrix which is having 9 elements. So a 3 cross 3 matrix has been given to us. And the value of x that we want to find is 34 here. So initially my low will be equal to 0 and my high will be equal to 8, because high is m into n minus 1. Now what will be the mid? When I'll calculate the mid for the first time, the mid will be equal to nothing but 4 here. Now what will happen is, the mid is 4. So the row will be mid divided by m. So 4 divided by 3, it will give me 1. So in the row with the index 1, my element will lie. Then after this, when I'll do 4 modulo 3, I'll get what? I'll get 1 here as well. So the element at the row 1, column 1, that is my mid element as of now. So the element here is 20. Now I'll check. So 20 is what? 20 is lesser than the target element x, that is 34. If 20 is less than 34, so I should search where? I should search on the right side. I should increase my I should search on the right side. So what I should do is, I should update my low as mid plus 1, because if at this mid particular index, the element that is lying in the row column, if it is lesser than the target element, so I should search on the right side of this mid. So increase the low to what? Mid plus 1. So now my low will be equal to what? Instead of 0, it will be equal to 5 now. Now when I take out the midpoint, what is the midpoint? So when I'll do 5 plus 8, it will give me 13. 13 divided by 2 will be what? It will be 6. So the mid as of now is 6. Now what will be the element that will be there? If you see, 6 divided by 3, it is going to give me 2. And 6 modulo 3, it is going to give me nothing but 0 here. So what is the element? The element at the row 0, the element at the row 2 and the column 0 is 30. Now 30 is what? 30 is also lesser than the element 34. So in this case, I want to search on the right side of mid again, because if 30 is less, so I want to search on the right side of mid. So update your low to mid plus 1. So what will happen is, now the low will be equal to nothing but 7 here. So when I'll calculate the midpoint will be 7 as well. Now identify what are the row and the columns. So the row will be basically equal to 7 by 3 here, and the column will be 7 modulo 3. So 7 by 3 will give me what? It will give me 2, and 7 modulo 3 will give me nothing but 1 here. So what is the element that we have? The element in the row index 2 and the column index 1, that is 34. I find out my target element. So in that case, what I'll do is, I'll return true that yes, the element was found. Now if you see here, whenever the element at the mid index if it is lesser than the target element, then I need to search what? I need to search on the right side of my low. So low will be updated as mid plus 1, and I cannot find the element directly at the mid. I'll basically find out the row and the column using the mid. And if the element is greater, in that case, what I need to do is, if the element is greater, then I need to search on the left side of mid. If the element at the mid index using the row and the column that I have found, if it is greater, so I need to search on the left side of mid. Otherwise, I need to search on the right side of mid. So depends on the condition. Now let's see the code as well. So you can see here what we will do is we'll find out the n, we'll find out the m as well. Then initially low and the high will be updated to 0 and m into n minus 1 respectively. Then we'll do what? We'll calculate the midpoint, and the row will be what? The row will be mid divided by m, and the column will be mid modulo with m. Okay, that's how we get the row and the column numbers. And then after this is a very standard approach, by the way, so you should remember this for other problems as well. Now after this, once we are done with this part, then we will do what? Because why we are dividing by m? Because the dependency is on the columns. The distribution of elements is dependent on the columns. How many elements we are giving to a particular column. So assume that if m value is 5, so we are giving 5 values to a particular column here. Correct. If we are giving 5 values to a particular column, in that case, we like when you divide by 5, so you will understand that if my mid value, let's say, is 6 here, so in that case 0 index is here 1 2 3 4 5 6. So 6, this element, according to the indexing 6, it will lie in the in the next row. So when I'll do 6 by 5, I'll get 1, so indicates that it should lie in this particular row. That is how it is going to help me. And how will I identify the column? So in every row, since I'm distributing 5 elements here, in every row the column size is 5, I'm distributing 5 elements each. So where does it lie? So 6 is there, so it is lying in this row, I know. Now 6 will be where? When I'll do modulo with 5, I'll get 1. So 0 will be here, 1 will be here, so it will lie here. That is how I can identify easily using the divide by m and the modulo with m strategy here. I have explained this above also, so I hope that this is crystal clear why we are using mid by m and the mid modulo m for the row and the column. Now after that, if the element at this row column is equal to x, then return true. Otherwise, if the element is less, then we need to increase the mid value. We need to search on the right side of this mid. So we'll do what? We'll update the lowest mid plus 1. Otherwise, if the element is lesser, then we need to if the element is lesser, then we need to update the lowest mid plus 1, because we need to search on the right side of this mid. Otherwise, if the element is greater, then we need to search on the left side. So update the highest mid minus 1. Same thing that we had discussed. In the end, if the element is not found, then return false. I hope you have understood this as well. The time complexity for this code, as I said, will be order of log of m cross n, because we are applying binary search overall on a single 1D array hypothetically here. Now let's try and submit this code and see if it is getting accepted or not. So you can clearly see that my code was able to pass all the test cases. I hope you are clear with this. Thank you for watching this video.